Hello?
Hello?
Hello? Oh. Alright, properties, definite integral. Objective, when you finish the section, you should be able to blah, 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 blah. Okay, so this is actually pretty easy. Properties 1 through 4 section require that a function be integratable. That means you have to take a integral of that function. Okay? Yes, has to exist. Continuous. So function f is continuous on a closed interval. Okay, is integratable over a to b. Function f is bounded on a closed interval and has at most a finite number of discontinuous on discontinuities on from a to b and integral. Wow, my left my cough drops at home, so I'm dying right now. I'm not allowed to take drugs from students anymore.
Not anymore.
Oh, I had cough drops too, but I gave it to Nessie.
Raindrop, cough drops.
Rain is fun too.
Okay. Anyway, all right. So let's just keep going here. All right. So two functions g and f are integratable on the closed interval a to b. Then the two functions over that same interval, I could actually have the integration of f plus the integration of g. So the sum, okay, I'm taking the sum of both of those together. That's all it means. So using the property of the definite integral here. So I'm going to use this property, so I'm going to break it into, it's going to turn into the integration 0 to 1 x squared dx minus 0 to 1 of e to the x dx. And that's all that means. That's all that means there. So let's go through and integration of this. So this is going to be, so my first one, my left one's going to be x cubed over 3 from 0 to 1 minus, that one's going to be e to the x from 0 to 1. Okay, remember you always add 1 to the exponent. Right now I'm starting with x squared, right? So you add 1 to the exponent and then divide by the exponent. So now, watch this. I'm going to show you a neat trick to figure this out. Now, can you take the derivative of that? What would you do to the derivative? The front, right? The exponent goes up front, right? So it would turn into, so the 3, and what do I do with the exponent? Subtract 1, and like that. So what's going to happen? So you're left with just back with x squared again. So the derivative and antiderivative should work back and forth to each other. Okay, so let's go ahead, top minus bottom. So it's going to be 1/3 minus 0, right? Minus, that's going to give me e to the 1 minus 1, right? Anything to the 0 power is 1. Thank you. So going together, distribute my negative. So it's going to be 1/3 minus e and plus 1. So that's going to give me 4/3 minus e. We okay? All right, theorem, integral constant times a function. We could bring that constant out front. So factor it out. Take it out in front of the integral, and then when you're done, multiply it in. That's going to be so helpful once we get to the next chapter. Because we're trying to find the volume. Okay, the volume is going to have a constant pi in there that you could take out. Okay, what's my constant here? 3. It's going to be 3, right? So my constant's going to be 3. So I'm going to take out 3 integral 1 to e of 1 over x dx. So that's going to be 3. And it's going to be, what is the, okay, integration is ln x. So ln of x, right? From 1 to 3, right? Or 1 to e, I'm sorry. There we go. 1 to e. Okay, so now from there, let's go through and keep going. So plug it in, top minus bottom. So what is ln of e? 1. Okay, so it's going to be 3 times 1 minus my lower bound. Ln of 1 is 0. So my answer is 3. Hey!
Isn't it the same as we did in warm-up?
Yeah, same as you did at the warm-up, right? So we can divide each one, right?
Yeah.
Okay, so that would be the first thing I would do there. And then once I'm done, I could see if there's any constant functions or constant factors, right? So I could also take something out of it. And that something's going to make my math a whole lot easier. What's that something going to be?
2.
Not a 2. Is the 2 on the bottom? Is the 2 on the bottom?
Yeah.
If I'm going to take out that 2, where would it be? If I factor it out, where would it go? It'd be in front, but what would it look like in front?
1 over 2.
Very good, 1 over 2. So it's going to be 1/2. So it's going to be, let's see, I'm going to break this up. 1/2 integration from 1 to 2. And then let's break up each one. So it's going to be 3x cubed over x minus 6x squared over x minus 5x over x plus 4 over x dx. So now that I did that, I can go through and set it up and then divide out each one. So again, it's going to be 1/2 my integral from 1 to 2 of 3x squared minus 6x minus 5 plus 4 over x dx.
Isn't it minus 5x? Oh, no, 0 to
Yeah, both x's cancel. And now let's integrate. 1/2 bracket. This is going to give me x cubed over 3, which is just x cubed. And this is minus x squared, right? But it's going to be over 2. So 6 over 2 is 3. This is going to be minus 5x. And this is going to be plus 4 ln of x from 1 to 2. Jess?
Yeah.
Okay, good. All right, top minus bottom. So it's going to be 1/2 times 8 minus 12 minus 10 plus 4 ln of 2, right? There's top minus the bottom, which is going to be 1 minus 3 minus 5. And this right here, the ln of 1 is 0 times the 4, which is just going to give me 0. All right, so let's go through. On the left-hand side, what do I get? I should have negative 14 plus 4 ln of 2. And this side over here, I'm going to get negative 7 plus 7. So it's going to give me a negative 7, right? Negative 7 plus 4 ln ln of 2. Okay, and all that, my answer is going to be over 2. I could divide each one individually by 2. So it'd be negative 7 over 2 plus 2 ln 2, right? Alright, so function integratable on an integral containing numbers a, b, and c. Then, from a to b, I can actually break it up into 2 separate parts. Okay, so I would put c right in between there, so it would go from a to c, and then c to b. So instead of just breaking it up from a to b, the whole thing, there's sometimes where I have to change it right here, where somewhere in between there, there's a point in which I have to change it. So it's going to be from a to c, and then the other side, which would be from c to b. It's integral if it's integratable on the closed interval. I know, right? Trying not to cough so much. Anyway, then integral 2 to 7. Then from 2 to 7 could be rewritten as from 2 to 4, and then 4 to 7, right?
On the second one, this looks really
I know it looks really weird. Okay? Now, look at this one right here. What can you tell me about those?
You're gonna.
Is it going backward?
Is it top minus bottom? It's supposed to be top minus bottom. Is those backwards now? The lower end is now on the top, right? What happens when you switch those? Minus. Thank you. It's going to become a minus. So this is going to turn into from 3 to 10. So this is going to be, so from integral 325 g of x dx minus integral from 10 to 25 of g to the x dx. Because I have to switch those. Whenever I switch them, that puts it into a minus sign there. So, by subtracting 10 to 25, that leaves me only left over from 3 to 10, right? So the whole thing, right? Look, 3 to 25, right? Because isn't 10 smaller than 25? Yes? And it should be the lower bound and then the upper bound, right? Yes? So whenever you switch those numbers, you change the sign. So it goes from a plus sign right here to a minus sign down there when I switch the bounds. So it goes from right here. So now think about your numbers. So if I have from 3 to 25, which is way beyond what I'm looking for, right? And I'm going to subtract from 10 to 25. So that means after I subtract from 10 to 25, what's going to be left over?
From 3 to
3 to 10. 3 to 10, right? Because I'm subtracting 10 to 25. Speak now. Oh, you got. Okay.
I think you
Tell
should
me what.
Draw the line.
Draw a number line?
Draw the graphic.
Okay, let's draw a number line. Insert page. Okay, so we have this number line. 3 here, 10 here, and 25. Okay? So, by bounds, let's take a look. What we have, it was, this is what we want right here. We only went from 3 to 10, right? Say yes.
Yes.
That's what we want. That's what we're starting with. That's what we want. Okay, so if I take the bounds, from 3 to 25, and I want that, what would I have to do?
I'll subtract the 10 and 25.
Subtract 10 to 25. Very good. Right? And when I subtract that, that leaves me with only this piece right here.
Okay.
Better sense?
Yeah.
Is everyone good now? Okay. Hello? Okay. All right, find the area under a graph of this function from 0 to 15. Okay, 0 to 15. Do I have this set up as parts here? This is a piecewise function, right? So it's basically g and x, or g and f, or f and g, right? So I'm going to take the integration, okay, from 0 to 10, right? And that's going to be of x squared dx plus integration of 10 to 15 of 100 dx. Because right here there is no variable, is there? No, it is that. Does that make sense? Okay, so top minus bottom, so it's going to be x cubed over 3 from 0 to 10, and it's plus 100 x, right? From 10 to 15. Okay, so what do we have? From x cubed over 3, 0, 10 plus 100, right? 100x from 10 to 15. Yes?
Good.
Okay, good. All right, so now this is going to be 1,000 over 3 minus 0 over 3, which is 0, right? Plus, right?
Yeah.
Plus, it's going to be, what's that going to be? 1500. Yes? Minus 1, 1, 2, 3, right? So that's going to be 100 or 1,000 over 3 plus 500, which is going to be over 1. So it's going to be, let me see, that's 15 and 1500. Yes? Are we okay? All right, so I'm going to save this one. I'm going to save this one right now. Okay, so we'll save this one for Tuesday. Okay? Tuesday. No school Monday.
Or Tuesday.
Oh my gosh.
Why is there no school on Tuesday?